Hello, Advanced Math. This is 12.2 ellipses. This is the third in our conic section series here. We're going to do hyperbolas, and then that will be it for our conic sections. Remember, a conic section is developed by taking two cones, putting them point to point. It's called a double napped cone. An ellipse is when you have a plane going through that at an angle. So this one might take a while. I got a lot of examples, and also there's just a lot of practice on this one I wanted you to have with it. So a little bit longer on this one. As I look through it, I think what we cover here in the notes should prepare you pretty well for it. Okay. The main thing I want to keep reviewing here is that completing the square process and working through that. So that's down when you go on to either higher level math or college algebra or whatever you do. Okay. So ellipses, we have again, we're going to have a general equation that we're going to cover with that, just like we've had for circles and parabolas. We're not doing differentiation with it. We'll use some properties of ellipses. Eccentricity, that is how elliptical is it, okay? If there's no eccentricity, then you have a perfect circle. But if you take a circle and start squishing it, then it's going to start having an elliptical path. That's a lot of times described the orbits of planets and the moons and stuff like that. They're not true circles, they're actually elliptical. So there are times you're a little bit closer to the sun and times you're farther away from the sun. Same with the moon to the earth. Okay, they're elliptical patterns because they come close and they go out, and then the gravity pulls them back in. It's actually an ellipse. Not much of an ellipse, but it is there. Okay, so the definition of an ellipse. It's the set of all points. Remember, we call that the locus. The locus is the set of all points, no T on there, L-O-C-U-S, in a plane, the sum of whose distances from two distinct fixed points, which are called foci, that is plural of a focus. So parabola had a focus. These are foci. There's two of them. Is constant. So if you're going to have two foci, you have a focus here, focus 1 and focus 2, and the distance from this focus to a point on the ellipse plus the distance from that point to the other focus will always remain the same. So D1 plus D2 is a constant. So it doesn't matter if you're here or if you're over here, D1 plus D2 is always going to be a constant. Okay? So that's the definition of an ellipse that we're looking at with this. Some of the terminology, the vocab. Okay, you're going to have a center of an ellipse. That's different than the foci. Okay, the center is different than the foci. We're going to have an x minus h, a y minus k. That's showing up again. The line that goes through the center on the longer side of the ellipse is called the major axis. Okay, so that one is the longer axis on the ellipse. On the major axis are what you call the vertices. Okay, there are no vertices on this other axis, which is called the minor axis. Okay, the minor axis, that is perpendicular to the major axis. Okay, college algebra, depending on the class, sometimes you get to start rotating these as well. We're not going to see that today. But usually that's the next step with these that you'd see in a college level class, is these conics get rotated in the graph. So the center, okay, here's your minor axis. The foci would be somewhere out here. So this could be F1, foci 1, foci 2, focus 1, focus 2. Okay, so the major axis is the longer one. The vertices are only on the major axis. Only on the major axis. Okay, so your visualization is if you would take two tacks and cut a piece of string between them, and then you make it straight, tight with your pencil, and you draw around as much as you can. That would be an ellipse, because that length of the string has to be fixed. It's not going to get longer or shorter. Okay, so if you do that, you draw it around, you're going to have an ellipse. I like how they say drawn taut with a pencil. Okay, I'm getting fancy with that. So here's your standard equation. Standard form of equation of ellipse with the center is HK, major and minor axes length 2A and 2B. Okay? So here are A's and B's. So we have x minus h squared, we've seen that before, y minus k squared, we've seen that, there's your center. And then it's over a squared and over b squared. So notice the major axis is horizontal and the A is underneath the X. When you go to a vertical major axis, so an ellipse that's more vertically shaped, like that, okay, notice the A switched to underneath the Y. So how I remember it is the direction of the major axis will have the larger denominator. Okay? So notice A is always greater than B. That's what this is saying here. A is greater than B. A is always greater than B. So if the A is underneath the X, you're going to have a horizontal major axis. If it's underneath the Y, you're going to have a vertical major axis. Okay? So whichever one has the larger denominator, that's the direction it's going. This formula here, C, that is the value of C is the distance from the center to the foci. It's going to be the same on both sides. Okay? So the foci lie on the major axis, C units from the center. C squared equals A squared minus B squared. So we could say C equals the square root of A squared minus B squared. Okay? If the center is at the origin 0, 0, the equation takes one of the following forms. And notice the minus h's and minus k's go away. So if you're at 0, 0, you're minusing zeros. That doesn't change anything. So if you have the center at the origin, you're using these formulas. If you have a center somewhere else, you can look at these up here. Okay? So here are both vertical and horizontal orientations. Hopefully you can see this. Here's H and K. The length of the major axis is 2 times A. So A is just this distance in here. A is the distance from the center to the vertex. B is the distance from the center up to the top of it in this case. So this is a horizontal major axis. A is underneath the X. And that's the distance from the center to the vertex or center to the top. Okay, same thing here. This would be B right here, and this would be A. Now the vertices are vertical because the A is underneath the Y. So the major axis is vertical versus major axis horizontal. Okay, so sketch a graph of the ellipse whose formula is below, then write the major axis length, minor axis length, and focal length. Okay? So focal length, that is the length of the length between the focuses. The length between the foci, and it equals 2 times C. So the major axis is 2A, minor axis is 2B, focal length is 2C. So we look at this. First of all, the center would be at positive 2, negative 1. X minus H, so H is 2. Y minus a minus 1, so Y is minus 1. So 2, negative 1. There's my center. Okay, so I look. My larger number is underneath the X. That means I have a horizontal ellipse. Okay? So A squared equals 9, so A equals 3. And that makes our major axis 2 times 3, 2 times A, which is 6. So I know I'm horizontal because the larger number is underneath the X. From my center, I'm going to go 3 units right, 1, 2, 3, and 3 units left, 1, 2, 3. Okay, I'm going to put little tick marks there. B squared is going to be 4 because B is the smaller denominator. So that means B equals 2. So my minor axis is 2 times 2, which is 4. So from here I'm going up 2 right there and down 2 right there. So this is your ellipse. We don't find any more points other than this. We do our best to draw an ellipse and not a diamond. You've drawn your first ellipse. Congratulations. Don't you feel accomplished? Final thing is the foci. So C is the square root of A squared minus B squared. So C is the square root. A squared was 9 minus B squared, which is 4, so that's the square root of 5. Okay, so that means our focal length is 2 times the square root of 5. Now the square root of 5, if you're graphing this, the square root of 5, I'm going to find a decimal to that, it's about 2.23. So they lie on the major axis, so 1, 2, 2.23, there's 1, 1, 2, really small there, so F1 and F2. So they're in there 2.23 units away from the center on the major axis. Okay? Okay, let's go the other way. Find the standard form of the equation of the ellipse with the given characteristics centered at the origin. So we're centered at the origin. We know we have an x squared over something plus a y squared over something, and it's going to equal 1. Ellipses and hyperbolas will always equal 1 in their standard equation. Okay, so this thing is going vertical, which means the larger number has to be underneath the y. So I'm going to go from my center, and I see that my a value is going to be 2, so that means I need a 4 here, because I have to do a squared. So it's y squared over a squared, x squared over b squared in this case, because we're vertical. Okay, hang on, that's 0, 4. This is counting by 2's here, so a should be 4, which makes this a 16. We're counting by 2's, 2, 4, so a is 4. Okay, b is going to be 2. That is the minor axis length, so this would be x squared over 4. So x squared over 4 plus y squared over 16 equals 1. There's your standard form equation. Find the standard form of the equation of the ellipse with vertices at plus or minus 7 and 0, and foci at plus or minus 2 and 0. And the center is at the origin. Yay, center at the origin. So x squared over something plus y squared over something equals 1. So the vertices are at plus or minus 7. So the vertices have to lay on the major axis. So the graph here is not something you have to use, but I enjoy graphing this out. It gives me a picture to what to look at. Helps me out. So 1, 2, 3, 4, 5, 6, 7. 7, 0. And 1, 2, 3, 4, 5, 6, 7. Negative 7, 0. Okay? So that means the length of my major axis is 14. That means a is 7. Since it's going horizontal, it has to be underneath the x. So it has to be a squared on this one, b squared on the y. Okay? The larger value always goes on the direction that you're going here. Okay, so for the b squared, we don't have a b here, but we do know the foci are at plus or minus 2. So remember, that is going to be our c value. So c is 2, a is 7. So we have the formula that c is the square root of a squared minus b squared. So if we plug in our a and c, we can solve for b. So we know c squared equals a squared minus b squared. So if I'm solving for b, I'm going to add the b over here, bring the c over here. So b squared equals a squared minus c squared. So b is the square root of a squared minus c squared. So now we have a formula for b that you can use. Whenever you need a b, you can come back to this formula. So that's the square root of a squared, which is 49, minus c squared, which is 4. So that's the square root of 45. So b is the square root of 45, which makes b squared equal 45, and that's what we're going to put underneath here. The square root of 45, that's almost 7. That's 6 point something. 2, 3, 4, 5, 6. Right there. 2, 3, 4, 5, 6. Right there. And now we can get an ellipse. You notice the major axis, the a value is 7. The minor axis, the value is almost 7, so this is going to be very close to a circle. Okay? Your foci, the closer your foci get together, the closer you have to a circle. And when your foci overlap, you have a circle. Okay? So if these two numbers are the same down here, that means your major axis and minor axis are the same lengths, and you have a circle. Okay. Find the standard form of the equation of the ellipse with the given characteristics. Okay, so we only have these points here. 2, 0, 2, 6. Notice it's vertical. And then we have 3, 3, and 1, 3. So I would draw a vertical line through here, and a vertical line through, or horizontal line through here. And the center, we need the center here. So the center is going to be a midpoint of either axis. midpoint of either axis. So if this is at 1, 3 and this is at 3, 3, we can assume that's going to be at 2, 3. So we have the top part, x minus h squared plus y. We have the top part of our formula. This is going vertical, so a squared will be underneath the y, b squared will be underneath the x, has to equal 1. Okay. So we have x minus 2 squared over something plus y minus 3 squared over something, equals 1. There should be something there. So the major axis is going up from here. This is at 2, 3. So 2, 3 to 2, 6, that is a length of 3. So A is equaling 3, so that means this has to be 9. B equals 1, so this has to be 1. Sometimes that 1 won't be there. It'll just say something like x minus 2 squared plus y minus 3 squared over 9 equals 1. B is the distance from the center to that point right there. Find the standard form of the equation of an ellipse with vertices, there we go, 0, 2, and 8, 2, and minor axis of length 2. Okay, so our vertices are at 0, 2, and 8, 2. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. So that means the middle of that, the midpoint, which is going to be our center, would be at 4, 2. So that is our center there at 4, 2. 2, 3, 4. Our minor axis has a length of 2, so the axis is length of 2. So 2 times b equals 2, which means b equals 1. So right there and right there. So very squatty ellipse. So we know our A is going to be 4, our B is going to equal 1 because A is the length from the center to the vertex, and our center is at 4, 2. So we're at x minus 4 squared over, it's horizontal, so the A goes here, 16, plus y minus 2 squared over 1 equals 1. Find the standard form of the equation of the ellipse having foci at 0, 1, and 4, 1, and a major axis of length 6, as shown in figure 12.15. So here we are, have this. I want you to imagine that B is not telling us, it's telling us B, so that makes it too easy here. But what we want to look at here is we have the A to be 3. Our major axis has a length of 6, so we know A is 3. So 2A equals 6, so A equals 3. Our foci are at 0, 1, and 4, 1. Again, the center is at the midpoint. So 0, 1, and 4, 1, the center would be at 2, 1. Okay, so that's what they have the center there. So we need to find the B. Oh, we already have a formula for B. And on this other side. Okay, remember B equals the square root of A squared minus C squared. Square root of A squared, A is 3, so 9 minus C squared. C is the distance from here to here, which is 2. So C equals 2, so 9 minus 4, so that's the square root of 5, which is what they have here. B is the square root of 5. So B squared equals 5. So we're going horizontal, so we have x minus 2 squared over 9 plus y minus 1 squared over 5 equals 1. Alright, let's see if we can get some more challenging ones. Find the standard form of the equation of ellipse with center at 0, 4. A equals 4c, and you have vertices at negative 4, 4, and 4, 4. So the center is at 0, 4, 1, 2, 3, 4. So we're going to have x squared over something plus y minus 4 squared over something equals 1. Vertices at negative 4, 4, 1, 2, 3, 4, 1, 2, 3, 4. And 1, 2, 3, 4, 4, 4. So if this is the center and these are the vertices, that means this is the major axis. And A is going to equal 4 here. So if this is the major axis, it's horizontal, A equals 4, this has to be 16. Okay. What we also know is that A equals 4C. So 4 equals 4 times C, so C has to equal 1. From that, we know B equals the square root of A squared minus C squared. So B equals the square root of 16 minus 1, which is the square root of 15. So that's the value of B. So B squared equals 15, and that's what would go here. Okay, very close. This would be very close to a circle. All right, completing the square. Sketch the ellipse given by this formula right here. So this is the general form, not the standard form, but the general form. X squared plus 4y squared plus 6x minus 8y plus 9. So we're going to group the x's together. X squared plus 6x plus blank. The y's together, plus 4y squared minus 8y plus blank equals negative 9 plus blank plus blank. Okay, now what you have to do with an ellipse, you see this 4 here. You cannot complete the square until that 4 is off that. So we have to factor out the 4 just out of this part here. So it looks like x squared plus 6x plus blank plus 4 times the quantity y squared minus 2y plus blank equals negative 9 plus blank. Now look at this. I factored out a 4 plus 4 times blank. Hopefully I don't need that part of my graph. Okay? Because whatever number you add here has to be multiplied by 4. That's the value you're actually putting on this side. So if you put a, we'll talk about that here. Okay, so to fill the blanks, you're going to take half of this number, half times 6, and then you square it. So half of 6 is 3, 3 squared is 9. Fill this blank, you're going to take half of 2 and square that, and you're going to get a 1. So I put a 1 in the blank, but I actually added 4 to this side because there's a 4 in it. 4 times 1 is 4. So I put a 1 over here, but if I added 4 on this side, I have to add 4 on this side. So that's why the 4 is there. Okay, factor. So x plus 3 squared plus 4 times y minus 1 squared equals negative 9 plus 9 is 0 plus 4 equals 4. Okay, if you did this correctly, this number right here should be half, just the half part, half of that middle number. Okay, now we divide all by 4. So we divide by 4, divide by 4, divide by 4. Because we remember it has to equal 1. It has to equal 1. So we're going to divide by whatever number we have over here. So I get x plus 3 squared over 4 plus y minus 1 squared over 1 equals 1. So your ellipse is going to have a center of negative 3, 1, 2, 3, 1. There's my center. A is going to be 2 and B is going to be 1 because A squared is 4. This is A squared and this is B squared. So A is going to be 2, B is going to be 1. It's going to be horizontal because the X has the larger number. So 1, 2, up 1, left 2, down 1. Very itty bitty tiny ellipse in there. There you go. Okay, so completing the square. Something that will be good to have in your toolbox. An application. Okay, we're going to see a little bit more of that later on. This one, I don't think you have any word problems, so I'm not going to deal with that. You have 2 times A is that, 2 times B equals that. You'd have to find the C value and work with that from there. Eccentricity. One of the reasons it was difficult for early astronomers to detect the orbits of the planets, our ellipses, is that the foci of the planetary orbits are relatively close to their centers. So the orbits are nearly circular. To measure the ovalness of an ellipse, you can use the concept of eccentricity. And here's your formula for eccentricity. These are the C's and the A's that we've been working with. So again, if your foci overlap, your C would be 0. Okay. So E ranges from 0 up to 1. So 0 can be less than E, less than or equal to E, which is less than 1. It can't be 1. Okay, that means C and A, that means your foci are on the vertexes, vertices, and then you don't have an ellipse, okay? So it can't be 1, but E is going to go from 0 to 1. Also, classifying conic sections, here's your general form, if you can see that, the ax squared plus cy squared plus dx plus ey plus f, okay? If A equals C, if you have the same coefficients for the x squared and y squared, then you have a circle. So you can know right away you're going to have a circle. If only one thing is squared, if just the x or just the y are squared, you're going to have a parabola. Okay? So if A or C, one of them are not there, you have a parabola. If A times C is positive, you're going to have an ellipse. And if A times C is negative, you're going to have a hyperbola. We'll look at that next. Okay? And again, if you look at that chart, this is just taken from that chart that I encourage you to print off if you have that opportunity. Okay. Identify the conic as a circle and ellipse, then find the center, radius, vertices, foci, eccentricity of the conic, whatever is applicable there. Okay? You're not going to have vertices if you have a circle. Okay? And sketch the graph. So you see down here, these are the same. That tells you you have a circle. Okay? Your radius is going to equal 5. It's the square root of 25. If you multiply each of these parts by 25, you're going to have x squared plus y squared equals 25. Okay? Which we've seen that as a circle. Centers at 0, 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So your eccentricity, okay, remember C is the square root of a squared minus b squared, which is going to be the square root of 25 minus 25, which is square root of 0, which is 0. So the eccentricity, E equals C over A, which is 0 over 5, which is 0. So a circle has an eccentricity of 0. Center, radius, the center is the origin. Okay, we're good. Let's move on. Identify the conic as a circle and ellipse, then find the center, radius, vertices, if applicable, sketch the graph. Okay, so this is in that general form. You notice we have different values here. We have a 9, we have a 4. Okay, so that tells us right away this is going to be an ellipse. Those are different values. Okay, so we get a practice completing that square. So I put my x's, 9x squared plus 36x plus blank plus 4y squared minus 24y plus blank equals negative 36. That gets kicked over. Plus blank plus blank. Okay, I have a 9 in front. I have to factor out that 9. So I have 9 times the quantity x squared plus 4x plus blank plus 4 times the quantity y squared minus 6y plus blank equals negative 36 plus 9 times blank, plus 4 times blank. Okay, put an extra parenthesis in there. You don't need that one. Okay, so I took the 9 out of both of those. It goes in front of that parenthesis. The 4 out of both of those goes in front of that parenthesis. Whatever goes in the first blank here gets multiplied by 9. Whatever goes in the second gets multiplied by 4. So I'm going to take half of 4 and square it. That's 2. That's going to be another 4. 4 goes there. I'm going to take half of 6 and square it. That's going to be a 9. 9 goes there. So when I factor, I get 9 times x plus 2 squared plus 4 times y minus 3 squared equals 36. So what happens in this case, when you divide by 36, 9/36 is 1/4. So I get x plus 2 squared over 4 plus y minus 3 squared over 9 equals 1. It's kind of just like the 4s and 9s just kind of switch spots, but you got to do a lot of this work to get the center. Make sure you get the center correctly. Okay, there are going to be some shortcuts you can figure out as you go through there, but that's generally it. Okay, so our center is at negative 2, 3. Our A value is going to be 3. It's vertical. Our B value is going to be 2. And our C is going to be the square root of 5. So negative 2, 3, 1, 2, 3. And so my A is 3, so 1, 2, 3, 2, 3. And then 2, 1, 2, Okay, so when you get to the assignment, they want you to actually list these points. So this is where the graph can come in handy. Okay, so your center's at negative 2, 3. Your vertices would be at negative 2, 0, and negative 2, 6. Negative 2, 0, negative 2, 6. Those are your vertices. Okay, what else do they want? So you put in the center, you put in the two vertices, the smaller y value and the larger y value, the two foci. So the foci is C is the square root of 5. So the foci have to be on this one right here. So I have to go root 5 units up. So my foci and root 5 units down, which is a little over 2. So my foci are about right here. So they're going to stay at negative 2, and then we have centers at 3, so 3 minus root 5 for one of your foci, and negative 2, 3 plus root 5 as your other foci. That's how your answers are going to be written with this. Okay, negative 2, 3 minus root 5, negative 2, 3 plus root 5. Okay, if you have a horizontal major axis, then that C value goes on the X. It'd be negative 2 minus root 5, negative 2 plus root 5, and your Y value stays the same. But since it's a vertical major axis, we're going to put it on the Y's. Eccentricity, E equals C over A, which is going to be root 5 over 3. Okay, and the square root of 5 divided by 3, that's about 0.74. I think they'd want this exact value, though. Okay, one more of those. Try to practice this on your own. Let's see, 3 times x squared plus 6x plus blank plus y squared minus 2y plus blank equals 8 plus blank plus 3 times blank. That 3 should have been in the first one. So 1/2 of 6 squared is 9. So I'm adding 9, and then I'm adding 1. So I get 3 times x plus 3 squared plus y minus 1 squared equals 9 plus 27, 36. So divide 36, you get x plus 3 squared over 12 plus y minus 1 squared over 36, that equals 1. So again, vertical. So A is going to be 6, B is the square root of 12, which is 2 root 3, and C is the square root of 36 minus 12, which is the square root of 24, which is 2 root 6. So sketching that, my center, here are my final answers. Center is at negative 3, 1. Center is at negative 3, 1. So 1, 2, 3, 1. So my vertices, if A is 6 and I am vertical because my larger number is underneath my Y, I have to go 6 units up. 1, 2, 3, 4, 5, 6. So that'd be negative 3, 7. 6 units up. And 6 units down. So negative 3, negative 5 would be the other one. 1, 2, 3, 4, 5. Okay. My foci. Okay, they're along the same axis, so it's negative 3. Now it's at 1, so it'd be 1 plus 2 root 6, and negative 3, 1 minus 2 root 6, okay? And to graph it, B is about 2 root 3, the square root of 12, that is about halfway between 3 and 4, 3.5-ish. 3.5, okay? The graphing part is multiple choice. You can also graph these on Desmos, that helps you, that takes care of that. The eccentricity is C over A, which is 2 root 6 over 6, which would be root 6 over 3. Square root of 6 divided by 3. 0.81. 0.81. Okay. So that should take care of those. Some of these, they say identify the conic as a circle and an ellipse, but then they ask for all of this, so you know right away it's pretty much an ellipse. If it's a circle, they're going to just say what's the center and radius. So graphs are multiple choice on those. The two vertices, make sure you're putting them in the right answer. Smaller y value, larger y value. Here you get into some of those bigger conics. I wanted you to practice some of those. So let me know what questions you have. Ellipses aren't that bad. Hyperbolas are going to be kind of similar. They look intimidating at first, but there's not a whole lot we have to graph. And if you get some of these key points, you can tell where the graph should be. So good luck, and I'll see you soon.